Welcome back, physics fans. We're going to do number 8 on the collisions worksheet for momentum. The momentum worksheet for collisions, number 8. A 75-gram marble flying along at 70 meters per second, holy smokes, runs into a 3.1 kilogram watermelon lying on a large table which has a coefficient of friction of 0.25. The marble sticks into the watermelon and then the pair goes sliding off onto the table. So this is a type of collision that is called completely inelastic because they stick together. Okay, so determine the velocity of the pair immediately after the collision. So this is a collision, and this is something that I would like you to be able to remember, that the momentum before is equal to the momentum after. There's two objects, so you go m1 v1 plus m2 v2 is equal to m1 v1 prime plus m2 v2 prime, but there's a special case here. So don't skip these things down. You're saying this is important. I'm saying this is important because there's two objects. Okay? There's a couple really easy things here, but why does it make it easier? First of all, there's two masses and four velocities, so there's six pieces of information, six pieces of info that we need. Okay, and mathematically, I'm going to give you five of them, and you have to calculate the six, and that's the whole idea logically here behind here. And some of the stuff that we get is that this is zero. This is initially zero. And it's one object. So V1 prime is going to equal to V2 prime. And I'm just going to call that V prime. They stick together, so they have to be the same velocity. And if they're the same velocity, let's simplify this. And if they're moving together, I can consider it as one mass. So in this question, this is what you need to do. Write those two down, because that's every collision with two objects is this in one dimension. And then special case is that this is just going to be m1 v1 is equal to, and now they're together, so we add the masses together, m1 plus m2 times v prime. This is the special situation for this collision. An object initially at rest being hit by another object and then sliding off. So this is a much easier equation. Why is it a much easier equation? Because beforehand there was four velocities, now there's only two. So we've gotten rid of two pieces of information. So in this question, at this point here, there's only 1, 2, 3, 4 pieces of information. So in this formula, we have four pieces of information, and we have three of them here. We have the mass, and we have the speed. So we have three pieces of information. We can calculate the fourth. Okay, there's the logic behind it. Let's go do it. So this is going to be a 0.075 kg marble flying along at 70 meters per second is going to equal 0.075 plus 3.1, and then the unknown, v prime. Okay, up comes Mr. Calculator. Clear that off. 0.075 times 70. So the total momentum of the marble is 5.25 kilograms meters per second. Okay, and we should probably figure out a direction there, but I'll just leave that blank. It's probably to the right or to the left or forward. Now the mass is going to be 3.1 plus 0.075. Okay, that's going to be kilograms. So we just take, to get V prime, we're going to take the 5.25 and divide it by the 3.175. we take that number divided by that number, and we get that the watermelon and the marble buried inside of it travel off at 1.654 meters per second, and whatever direction that was. So the direction that was in here is the direction that's going to be in here. Okay, pretty good information. I'm just going to move this pieces information calculation over here. In that formula, and over in here we only have 4, because I want to use this area here to do part B. So how far do they travel before coming to a stop? So VF is 0, okay? And how far do they travel is what we were trying to figure out, D. And we have that the initial speed is 1.654. It looks like we don't have enough information. But we have this weird piece of information that they gave us, the coefficient of friction. Free body diagram. There's a normal force. There's a force of gravity. It's moving this way. It's going to be outside of our free body diagram, so that means friction is moving in the opposite direction. And that's going to be the net force. So the force of friction is going to be the net force in this case. Okay, so we could calculate the force of friction. Force of friction is equal to mu mg, which is going to be 0.25 times the mass of 3.175 times 9.8. 0.25 times 3.175 times 9.8. We're going to get a frictional force of 7.779 newtons, and that's in the opposite direction. And that's going to be the equal to the net force. So F net is equal to MA. So this gives us A is going to equal F net over M. So A is going to equal 7.779 newtons divided by 3.175 kilograms. So the acceleration is going to be this number divided by that number, and we get 2.45 meters per second squared. And that's going to be in the opposite direction, negative. So, highlighting the things that we have, kinematically, we have final velocity, we have initial velocity, and we have acceleration. Calculate D. We use the kinematic formula of this. Let's just give us a little bit of room here, put a dotted line here because we're changing from dynamic calculations above to the kinematic. So Bf squared is equal to Vi squared plus 2AD. So the stopping distance is going to be Vf squared minus Vi squared all over 2A. And that's going to equal 0 minus 1.654 squared all over 2 times a negative 2.45. Negative because it's in the opposite direction, but we'll have a negative up top and a negative down below, so we get our positive distance out, and that's what we wanted. And so I take the speed, square it, and divide it by 2, and also then divide it by this acceleration. And Mr. Calculator says just over a half a meter. Lengthy question. But there's our photo op. Those people on the internet, there you go. Pause it. Make sure you capture it. Thank you.